Multiply mixed numbers, page 130. Now, for example, we have already kind of done part of the process that you'll need to do today on the assignment that you had for today. The first thing that we put up on the board yesterday about multiplying and dividing with fractions was that in order to do so, everything needed to be in fraction form. On your assignment for today, you came across problems that look similar to this. You had a regular fraction like half, and you had a whole number. You had to fix and rewrite the whole number in fraction form, and we had 3 over 1. Because anytime you want to put a whole number into fraction form, you put a bar underneath it, and you put a 1 underneath the bar. What kind of fraction is that when the numerator is larger than the denominator? Say, improper. So it doesn't matter if that fraction form means that they're improper. It just means that we need a top number and a bottom number. Okay? So we would go ahead, 3 over 2, and then we simplified this improper fraction by saying 2 goes into 3, Desi, 1, denominator stays the same, and if I take 2 away from the 3, like you said, 1. Okay? All right. Well, we'll do another one, and we'll do another one like you'll see more often today. So let's take a look at one like this. Let's use half, and we'll multiply it to 2 3/4, because that there is a mixed number. I remember way back when we estimated and we did all that stuff, in the past, if it was a regular fraction, we just said 0, half, or 1. Well, that's going to be half, right, if we were estimating? And if it was a mixed number, we said we always rounded to the nearest whole number. So 2 3/4 would be 3. So half times 3, or half of 3, is what? About 1 1/2. So we should get an answer about 1 1/2, right? Good. So half of 3. So here, the half is already in fraction form. Now, we need to change this into a fraction, and the only way to do that with a mixed number is to make it an improper fraction. So I multiply my whole number times my denominator, and I get 8. And I do what with the numerator? Add the numerator. So 8 plus 3, what's the denominator? What we started with. Now, we've got everything in order. Nothing diagonally that's in common. I'm going to get 11 over 8 simplified. 8 goes into 11 one time. And how many are left? 3. What do we say our answer should be around? How does that size up with 1 1/2? Really close, right? Because it's really close to that 4. So we're good. Yeah, we'll do more than, yeah. So let's estimate first, just so we know about what we're looking at here. 5 4 seventh. We're going to go to 5 or 6. 6. 1 2/3. Are we going to go 1 or 2 for a whole number? 2. So I should get something in the ballpark of 12. Now, neither of these this time are in fraction form, so I need to put them both into fraction form. Now, remember the process. multiply the whole number times the denominator, and we get 35, and then we add the numerator, so we get 30. Denominator will stay at a 7. Times, multiply your whole number times your denominator, 3 plus the 2 over 3. Before we do any multiplication, especially now, because I don't really want to do 39 times 5 and then divide it by 21 if I don't have to. So I ask myself, do 39 and 3 have anything you can divide both by? Carlos? 3. So I have 1 3 there. How many 3s in 39? 13. Yep. Yeah?
Okay, so every time you get a like the mixed number, you always add multiply the denominator.
Can we finish and then we'll go back? Let's just finish this off. 13 times 5 is and 7. How many times is 7 going to 65? Alexis? 9 gives me 63, right? 9 times 7. So 2 left over 7. Now 9 and 2 sevenths, and we thought it was 12. But we also went over, we went from 5 and change to 6, and we also went from 1 and change to 2. So our estimate was a little on the high end. So 9 and 2 sevenths works just fine. So yes, Casimir, to answer your question, we will multiply denominator and whole number, and then add the numerator to that, and then put it over the denominator. Okay? Any questions? Try it. Let's estimate. Then round to 5, that rounds to 2. I should get something in the ballpark of 10. Now, let's take a look. 4 times 6 is 24. 24 plus 5, 29 over 6. 2 times 4 is 8, plus 1 is 9 over 4. Now, 29 is a prime number, so you know that there's not going to be a whole lot that it's going to be divisible by. In fact, if it's prime, it's only divisible by 1 and 29, which 4 is not divisible by 29, that's for sure. So this is, we're going to have to leave this alone. But 9 and 6, they're both divisible by 3. So that's a 3, and that's a 2. 29 times 3 is 87. 2 times 4 is 8. 8 into 87, 10 times gives me 80. How many are left? 10 and 7 eighths. Close enough to 10? Sure. Two and 2/3 times 4 1/2. Okay, an estimate. 3 times 5 and 15, and that would be a high estimate because we rounded up on both of them. So 2 times 3 is 6, plus 2 is 8 over 3. 4 times 2 is 8, plus 1 is 9 over 2. Now this works out really well. 8 and 2 are both divisible by 2, so we will simplify that. 9 and 3 both divisible by 3. We will simplify that. Watch how easy this is now. 4 times 3 is 12. 1 times 1 is 1. Anytime we saw a number with 1 as the denominator, we knew It was just that as a whole. So another benefit of making sure that you do all of your reducing here, and then it was easy. Like, what did you have, 72 over 6? That's 12, isn't it, or no? That's 12. So if you don't know, like, Liam had 72 over 6, and he was just sitting there. Like, I don't know if you ever figured it out, or you just sat there. If you don't know what it is, then what do? Set it up. Set it up, and then just do the work. Doesn't matter. Liam, it doesn't matter. You could still get it, but you have to do the work to get it if you don't have it. Okay? Another one?
No.